Welcome back to my channel. This is WireDogSec, back with another video for you guys. And today's video, we are continuing on with the Junior Penetration Tester learning path inside of TryHackMe, the introduction to web hacking area, and we are in the file inclusion room. This room introduces file inclusion vulnerabilities, including local file inclusion, also known as LFI, remote file inclusion, also known as RFI, and directory traversal. Now let's go ahead and dive into it. Task 1, Introduction. What is file inclusion? This room aims to equip you with the essential knowledge to exploit file inclusion vulnerabilities, including local file inclusion, LFI, remote file inclusion, RFI, and directory traversal. Also, we will discuss the risk of these vulnerabilities if they're found and the required remediation. We provide some practical examples of each vulnerability as well as hands-on challenges. In some scenarios, web applications are written to request access to files on a given system, including images, static text, and so on, via parameters. Parameters are query parameter strings attached to the URL that could be used to retrieve data or perform actions based on user input. The following diagram breaks down the essential parts of a URL. And let's take a look here. You got the protocol here, HTTP. You got the domain name, which is webapp.thm, the file name, get.php, the query string, which is a question mark, and you got the parameters, file equals whatever this PDF is. All right, for example, parameters are used with Google searching, where get request pass user input into the search engine. And this is what one looks like here. So you have Q equals TryHackMe. If you are not familiar with the topic, you can view the How the Web Works module to understand the concept, or you can just check out my videos over this stuff. Let's discuss a scenario where a user requests to access files from a web server. First, the user sends an HTTP request to the web server that includes a file to display. For example, if a user wants to access and display their CV within the web application, the request may look as follows. And this is what it looks like here. This is file equals user cv.pdf, where the file is the parameter and the user cv.pdf is the required file to access. All right, and this is what it looks like. A little diagram here, user requesting access to that PDF, hitting that server in the back, it's going in, doing its searching, right? The get to PHP is going through, search through all these directories, and it located the PDF and it sends it back to display to the user through the web browser. Why do file inclusion vulnerabilities happen? File inclusion vulnerabilities are commonly found and exploited in various programming languages for web applications such as PHP that are poorly written and implemented. The main issue of these vulnerabilities is the input validation, in which the user inputs are not sanitized or validated, and the user controls them. When the input is not validated, the user can pass any input to the function, causing the vulnerability. What is the risk of file inclusion? By default, an attacker can leverage file inclusion vulnerabilities to leak data such as code, credentials, or other important files related to the web application or operating system. Moreover, if the attacker can write files to the server by any other means, file inclusion might be used in tandem to gain remote code execution, RC, right? You can get a web shell on there. All right, so we've already going to deploy this virtual machine here, which is VM. Deploy the attached VM to follow and apply technique as well as do the challenges in order to access the VM. Please make sure to connect to TryHackMe network via OpenVPN or access directly to the attack box, which I'll be doing it through the attack box, which can be launched by clicking the blue button on the top right. It says please visit this link here, which should look as follows. This is what it's going to look like here as soon as I get into the show split screen. So I'm just going to hit complete here, and then let's go ahead and continue on to path traversal. Path traversal, also known as directory traversal, a web security vulnerability, allows an attacker to read operating system resources such as local files on the server running an application. The attacker exploits this vulnerability by manipulating and abusing the web application's URL to locate and access files or directories stored outside the application's root directory. Path traversal vulnerabilities occur when the user's input is passed to a function such as file underscore get underscore contents in PHP. It's important to note that the function is not the main contributor to the vulnerability. Often poor input validation or filtering is the cause of the vulnerability. In PHP, you can use the file get contents to read the contents of a file. You can find more information about the function here. So click that if you're interested. The following graph shows how a web application stores files in var www app. The happy path would be the user requesting the contents of user cv.pdf from a defined path var www app cvs. And here's an infographic of what this looks like here, this process here. You can see the attacker is doing something malicious here. They're looking for Etsy past WD. They sent the request over, and it looks like they got it back. Past WD's content. We can test out the URL parameter by adding payloads to see how the web application behaves. Path traversal attacks, also known as the // attack, take advantage of moving the directory one step up using the double dots, which is // if the attacker finds the entry point, which in this case get.php file equals, then the attacker may send something as follows. And this is what it looks like here. You can see there it's got the // etc., here. Suppose there isn't input validation, and instead of accessing the PDF files at var www app CVS location, the web application retrieves files from other directories, which in this case is Etsy past WD. Each entry moves one directory until it reaches the root directory, which is /. Then it changes the directory to /Etsy. And from there, it read the past WD file. Here's another infographic of this process here. As a result, the web application sends back the file's content to the user, right? And now we can see the contents of the past WD, which is going to show like the user counts on this machine here. Similarly, if the web application runs on a Windows server, the attacker needs to provide Windows paths. For example, if the attacker wants to read the boot.ini, the file located in c boot.ini, then the attacker can try the following depending on the target's OS version. And this is what it looks like here. The same concept applies here as with Linux operating systems, where we climb up directories until it reaches the root directory, which is usually a C:\\. Sometimes developers will add filters to limit access to only certain files or directories. Below are some common OS files you could use when testing. All right, I'm not going to read through all this here, just a couple of them, but you can go back and take a look at and read through all these yourself. Etsy issue contains a message or system identification to be printed before the login prompt. Etsy profile controls system-wide default variables such as export variables, file creation, mask, unmask, or umask. Terminal types, mail messages to indicate when the new mail has arrived. Proc version specifies the version of Linux kernel. Etsy past WD has all registered users that have access to the system. Etsy shadow contains information about the system's user's password, etc., etc. What function causes path traversal vulnerabilities in PHP, as we saw up above here? All right, it was this here. This file get contents was what they're referring to. So let's go ahead and copy and paste that down there and then continue on. All right, task number 4 here, we're going to be talking about local file inclusion. LFI attacks against web applications are often due to a developer's lack of security awareness. With PHP, using functions such as include, require, include underscore once, and require underscore once often contribute to vulnerable web applications. In this room, we'll be picking on PHP, but it's worth noting LFI vulnerabilities also occur when using other languages such as ASP, JSP, or even in Node.js apps. LFI exploits follow the same concepts as path traversal. In this section, we'll walk through various LFI scenarios and how to exploit them. Number one, suppose the web application provides two languages and the user can select between EN and AR. And here's an example of it. PHP include get lang. The PHP code above uses get request via the URL parameter lang to include the file of the page. The call can be done by sending the following HTTP request as follows, and this is what it looks like here. Lang equals en.php to load the English page, or lang equals ar.php to load the Arabic page, where en.php and ar .php file exists in the same directory. Theoretically, we can access and display any readable file on the server from the code above if there is an input validation. Let's say that you want to read the etc_pass_wd file, which contains sensitive information about the users on the Linux operating system. We can try the following. And you can see how they got it out here. They got the get.php question mark file equals etc_pass_wd. In this case, it works because there isn't a directory specified in the include function and no input validation. Now apply what we have discussed to try to read the etc_pass_wd file. Answer question number 1 below, which says give lab number 1 a try to read the etc_pass_wd. What would the URI be? So let's go ahead and try lab number 1. Hey everybody, just a quick little blurb here. As you can see here, most people that view my channel are not subscribers. If you're new here, please consider subscribing to the channel. If you're enjoying the video, please consider hitting the like button. It helps get me in the algorithm, helps spread the good word out there, helps bring more people and increase our glorious community here. All right, I'm all about helping out others. I know what it's like to come up in cybersecurity or even try to get into cybersecurity and not knowing where to look. I'm just having this channel up so I can help out other people. All right, that's all I got. We're in here. Now, first thing I want to do is just click this include button here, get some information. Sometimes we'll find some interesting information in the error codes and such like that. But anyway, you can see up here file equals whatever. So let's just try etc_pass_wd, see if that works. And bam, there you go. See how we got the file contents of pass_wd. Now we can see the registered users on the system. Now let's go ahead and copy and paste this out of there. And let's see. All right, so looks like they just want this part here. Right, so let's just do it this way. Let's do back here and then copy and paste this stuff over. Here we go. And then etc_pass_wd. That should be it. There we go. Lab number 2. What is the directory specified in the include function? So let's go back to up here first to read about it. Okay. So number 2. Next, in the following code, the developer decided to specify the directory inside the function. PHP include languages / get lang. In the above code, the developer decided to use the include function to call PHP pages in the languages directory only via lang parameters. If there's no input validation, the attacker can manipulate the URL by replacing the lang input with other OS-sensitive files such as etc_pass_wd. Again, the payload looks something similar to path traversal, but the include function allows us to include any files into or any called files into the current page. The following will be the exploit. All right. Now apply what you would discuss. Try to read the files within the server and figure out the directory specified. The include function, answer number 2. All right, so let's see. It appears that this includes file here is what they are looking for, or this directory here they're looking for. So go ahead and plug that in there, and let's continue on to task number 5. We're going to talk about local file exclusion, continuing with number 2. In this task, we go a little bit deeper into LFI. We discussed a couple of techniques to bypass the filter within the include function. Number 1 is the first 2 cases. We checked the code for the web app, and then we knew how to exploit it. However, in this situation, we are performing black box testing in which we don't have the source code. In this case, errors are significant in understanding how the data is passed and processed into the web app. In this scenario, we have the following entry point, which is this here, index.php, lang equals en. If we enter a invalid inputs such as thm, we get the following error. Warning, include languages thm.php failed to open stream, no such file directory, var yada yada yada. The error message discloses significant information by entering thm as input. An error message shows what the include function looks like, include languages thm.php. If you look at the directory closely, we can tell the function includes files in the languages directory, is adding .php at the end of the entry. Thus, the valid input will be something as follows: input.php en.php lang equals en, where the file en is located inside the given languages directory and named en.php. Also, the error messages disclose another important piece of information about the full web application directory path, which is var www html thm4. To exploit this, we need to use the // trick as described in the directory traversal section to get out of the current folder. Let's try the following, which is this here, // etc. Note that we use for // because we know the path has 4 levels: var www html thm or -4. But we still receive the following error: warning, include languages blah 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 failed to open, no such file or directory, and yada 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 on line 12. It seems we could move out of the PHP directory, but still the include function reads the input with the .php at the end. This tells us that the developer specifies the file type to pass to include function. To bypass the scenario, we can use a null byte, which is %00. Using null bytes is an injection technique where URL encoded representation such as %00 or 0x00 in hex with user supplied data. To terminate strings, you could think of it as trying to trick the web app into disregarding whatever comes after the null byte. By adding the null byte at the end of the payload, we tell the include function to ignore anything after the null byte, which may look like the following here. All right, this is what it looks like with the null byte, and then this is the equivalent to the following. Note the %00 or null byte trick is fixed and not working in PHP 5.3.4 and above. Now apply what we showed in lab number 3. Read the files of etc pass wd. Answer question number 1 below. All right, so let's see. Give lab 3 a try. So let's go navigate to lab 3 real quick. Try to read etc pass wds. All right, so let's see. All right, now first things first, hit to include. See what we can find out from the error messages, and you can see some information here. File directory in var www blah 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 includes /.php. All right, file include equals the following, yada yada yada. All right, and current path is this var www html, and we need to navigate back. So in order to do this, you'll have to use the .. as I explained earlier, and then you'll have to add the null byte at the end so you can bypass those filters in there. I believe that's what they said up above, but this was fixed in a later version. But anyway, now let's go ahead and run this, and now we can dump the information out of the passwd file. All right, so I'm just going to copy and paste this information over here. Oh, grab all of it, make sure. All right, so I'm going to grab all this out of there, and there we go. Which function is causing the directory traversal in lab number 4? So let's go back up there and do some more reading. All right, number 2 in this section, the developer decided to filter keywords to avoid disclosing sensitive information. The etc passwd file is being filtered. There are 2 possible methods to bypass the filter. First, by using the null byte or the current directory trick at the end of the filtered keyword. The exploit will be similar to the following. We could also use this, right, with the null byte in there. To make it clear, if we try this concept in the file system using cd, it will get you back 1 step. However, if you do it with cd dot, it stays in the current directory. Similarly, if we were to try etc passwd and then .. it would result in etc, and that's because we moved 1 to the root. Now, if we try etc passwd, the result will be etc passwd, or sorry, passwd dot, the result will be etc passwd, since the dot refers to the current directory. Now apply this technique in lab number 4 and figure out how to read the file in there. All right, so let's scroll back down here to this, what's causing it. So, all right, let's take a look. Error code here. File get contents, function, yada, yada, yada. So let's go back and reference what they just explained up above here. All right, now, as I explained earlier, we'll need to use this dot at the end All right, so we're looking at the current directory. Hit enter here, and then as you can see, we were able to obtain the file contents of etc passwd again, using that to bypass any filtering or whatever. All right, it says which function is causing the directory traversal. So let's see here. It looks like this get files contents is what's causing the issue. So let's go ahead and plug this in here. There we go. And they explained earlier about the issue with this file get contents, right? All right, try out lab number 6 and check what is in the directory that has to be input in the field. All right, so let's go back up here and continue on where we left off. All right, next in the following scenarios, the developer starts to use input validation. By filtering some keywords, let's test out our luck, checking error messages. All right, which we've already done this. We got the following error, right? Failed to blah, blah, blah. If we check the warning messages include a language's etc passwd section, we know that the web application replaces the dot dot forward slash with the empty string. There are a couple of techniques we can use to bypass this. First, we can send the following payload to bypass it, which is this here. Why did this work? This works because the PHP filter only matches and replaces the first subset string, which is dot dot forward slash, which is why they do those extra dot in there and then the extra forward slash. It finds and doesn't do another pass, leaving what is pictured below. This is what it looks like, right? You have to bypass right here, and then this is what it's going to look like on the other end. Try out lab number 5. Try to read the etc passwd file. All right, so let's go to lab number 5 here. Okay, so let's go ahead and check the error codes here. Using this includes again. All right, so let's go ahead and try what they're talking about here. Let's just copy and paste this over like so. And there we go. See how that worked? We're able to pull the content files, file content of passwd again using this bypass. All right, number 4. Finally, we discussed the case where the developer focuses or forces the include to read from a defined directory. For example, if the web application asks to supply input that has to include a directory, such as the following, then to exploit this, we need to include the directory in the payload like so. All right. Try out this for lab number 6 for what the directory has to be present in this input field is. Okay. First things first is to generate some kind of error code. Current path, file content preview of access denied, allowed files at thm dash profile folder only. Well, that seems interesting, this thm profile, and you can see something here in this example. So basically, you're going to copy this thm dash profile and you're going to combine it with the dot dot forward slash criteria as well as etc passwd. So go ahead and plug that in there, put enter, and now we can see the contents again of passwd field. What is the directory that has to be in the input field? Well, we know that from looking at the error code. It's going to be this thm profile directory. So let's go ahead and put that in as the answer. Oops. All right, there we go. Try out lab number 6 and read this following. Etc OS release, what is the version ID value? Okay, so let's go ahead and copy this out. And let's try the same thing. Same thing here. Let's replace etc passwd with this information like so, and then let's try it this way. There we go. And it says the version is 12.04. All right. Task number 6 is remote file inclusion, also known as RFI. RFI is a technique to include remote files and into a vulnerable application. Like LFI, the RFI occurs when improperly sanitizing user input, allowing an attacker to inject an external URL into include function. One requirement for RFI is that the allow underscore URL underscore f open option needs to be on. The risk of RFI is higher than LFI since RFI vulnerabilities allow an attacker to gain remote command execution (RCE) on the server. Other consequences of a successful RFI attack include sensitive information disclosure, cross-site scripting (XSS), denial of service, which is DOS or DOS. An external server must communicate with the application server for a successful RFI attack where the attacker hosts malicious files on their server. Then the malicious file is injected into the include function via HTTP request, and the content of the malicious file executes on the vulnerable application. Here's what it looks like here, step by step. If you want to pause the video, take a look at that. RFI steps. The following figure is an example of steps for a successful RFI attack. Let's say the attacker hosts a PHP file on their own server, which is this here, attacker.thm.cmd.txt, where cmd.txt contains a printing message of hello thm. And there's something what it looks like here, echo hello.thm. First, the attacker injects the malicious URL, which points to the attacker server, such as the following here. If there is no input validation, the malicious URL passes into the include function. Next, the web app server will send a GET request to the malicious server to fetch the file. As a result, the web app includes the remote file execution or file into include function to exclude or execute the PHP file within the page and send the execution content to the attacker. In our case, the current page somewhere has to show the hello THM message. Visit the following page. So let's go ahead and copy this out. Actually, we can just go to it through here. There's playground. There we go. And all right, we're going to try out some RFI attacks here. Answer the following questions. We showed how to include PHP pages via RFI. Do research on how to get remote code execution and answer the question in the challenge section. All right, so we're going to take a look at that here shortly. But let's go ahead and continue here to task number 7, remediation. As a developer, it's important to be aware of web application vulnerabilities, how to find them, and prevention methods. To prevent the file inclusion vulnerabilities, some common suggestions include the following here. Keep system and services, including web application frameworks, updated with the latest version. Turn off PHP errors to avoid leaking the path of the application and other potentially revealing information. And you can read the rest here. Web application firewall known as a WAF, etc., etc. All right, answer the questions below. Ready for the challenges? Yes. So let's continue to task number 8 and take a look at these challenges. Great job. Now apply the techniques we've learned to capture the flags. Familiarizing yourself with the HTTP web basics. Continue, or could you help complete these challenges? Navigate to challenges .php here, or index.php. Steps for testing LFI or following. All right, so let's backstep real quick to this RFI thing they want us to take a look at here. So let's play around with this real quick, and then we'll go back to number 8. Now, if you're in here in the playground area and testing out the RFI capabilities, exploits, etc., you can do something like this. As you can see, I just made a quick little test uh, document here. So let's go back and try to recreate the steps I did, clear all this out. First, I got a web server up and running using Python 3, right, running on port 8000. Next, I created a document here, so called test document. This is a test. Ha ha ha. Whatever. All right. So I want to pin that to this test document, right? Now I'm going to navigate over. Now, if you're confused on where your document is located, you can always navigate to the specific URL they had listed out here for this HTTP server, right? So this is where I'm at inside my own box because I got this web server running, and there's my file, right? And if I go to it, you can see this is a test, haha, right? Now, what I'm going to do is basically go in here and type in the location of your web server, right? You got the IP in here. This is the IP of the machine. The web server is running on port 8000, and the file I want to access is going to be this test.txt. So if I go ahead and hit enter here, now you can see how it changed at the bottom, right? This is a test, ha ha ha, whatever. Now let's continue on to answer some of these questions here for these flags. All right, the first challenge here is to find flag number 1. I already have my payload ready to go here, and I'm going to be using this in burp. So I have my proxy set to burp settings, and I have burp Community Edition already up and running. Intercept is turned on to make sure that's set correctly. Now I'm going to go in here and it says we need to use a post request. All right, so I'm going to hit this first so I can get the traffic inside of burp, right? Right click here and send it to repeater. Now, while it's in repeater, make sure to right click inside of here and you're going to change request method to post. All right, now what you're going to do is hit the send button at the top here to resend the request. And as we scroll through here, we will find the flag, which is this here, code. So there you go. Now let's continue on to challenge number 2. Lab challenge number 2 here. All right, we're going to be messing around with some cookies. Remember cookies? Not Cookie Monster, but you get the gist. All right, so you're going to open up your developer tools and you're going to go to the storage section here, storage tab, and it wants us to refresh the page. So let's go ahead and refresh the page. All right, it says welcome guest, only admins can access this page. Okay, well, looking at this cookie here, it says the value is guest. Well, what happens if I change that to admin? Let's see it and find out. Hit refresh, and now it says welcome admin, and it's got some more information here that we can take a look at here. And it's talking about this includes admin.php, function.include, yada, yada, yada. Now we need to make some more edits in here because we need to find flag number 2, right? So you can try to do the same thing here. Now this is going to be our input point here. And let's just try flag number 2 without the actual null byte at the end. So hit enter, hit refresh, and it said it went through, but it's still not displaying the contents of that flag. Now, what you want to do is you got to go back in here and you got to put in the null byte, which was the percentage 100. So type that in, percentage 100, or sorry, not percentage 100, percentage 00. There we go. Hit enter and then refresh the page, and then voila, there's the contents of that particular file. Now let's continue on to the next challenge. Challenge number 3. Now, as usual, you can hit include here, try to figure out some information from the error codes here, include.php, include, etc., etc. You go in, you can try typing in some things, see if it'll do anything. Let's just use this as an example. Nothing. All right, try another one in here. Let's try it like this. See if anything comes in. Nothing. But if we notice file preview of Etsy flag, right? It's taken out the / as well as the number 3. So it's doing some filtering. So you got to do a couple bypasses here. So let's just go ahead and type in test. And then I'm going to flip on burp. Flip the settings back over in Foxy Proxy. And make sure your cookies are cleared out. All right, inside of developer tools. Make sure there's no cookies in there from the last challenge. But anyway, so let's go ahead and hit enter or include here. Go back over to burp and see how it has captured the information here. You're going to right click here and you're going to send to repeater. So let's go ahead and do that. Now inside of repeater, there was an area in here where we had to change the HTTP request. As you can see, this is a GET request. Now let's go ahead and change this to a post request as we did in a previous challenge. Now for this particular one, you can go ahead and do the same payloads here, and you can try it without the actual null byte and hit send, see what it does, see if this actually renders. No, it does not. But you go over and look at the pretty, and you can see if anything changed, right? So scrolling through here, file contents of this. Now, as you can see, it did not remove that / and the number 3 like it did before. So it looks like this is somewhat working, right? Now, what happens if we add in the null byte to bypass another filter? Set it in here, and you go ahead and take a look at the results. And you can see that we have the last code here. Post is working. So you had to do quite a few different filters here, and you had to change the request in order to get this to bypass and execute properly. All right, now let's continue on to the last objective. We've reached the final challenge, and basically it's to get a RCE that generates the host name of the server. All right, now we're back in the playground area because this is where you're going to do it. Now remember, from before where we used the test file, right? And it gave us this information. Now, you're going to basically do the same thing, except you're going to create a file in here called whatever. I called mine hostname, and I opened it in Nano. Inside of Nano, I entered this criteria here, print exec hostname. All right, so just to show you what it looks like. All right, inside of Nano, hostname, and this is what's going to be displayed on the screen here in a second. So let me exit out of here. Same thing with who am I. I put who am I instead of hostname. But let's go ahead and go to my file here. So I'm going to change this to hostname. There we go. Now we have the hostname. Same thing with who am I. Who am I? Right? www.data. Now let's go ahead and navigate back over and close out the video. I'm sure you can do more with this, so play around with it if you choose to. Maybe get a web shell or something on there if you can. Anyway, let's go ahead and continue on and close out the video. That wraps up the video, folks. As you can see, we learned quite a few things about LFIs and RFIs, how to possibly bypass those particular vulnerabilities and such. Be sure to get some practice in, familiarize yourself with these two different vulnerabilities. I'm not sure how often you'll come across these in like bug bounty or even if you're penetration testing against a client web application, etc. But hey, it's good information to know. I'm sure these vulnerabilities still exist out there in some form or fashion. Same with the IDOR vulnerabilities. They're still out there in some form or fashion. Maybe they're less common these days due to improved security practices, etc., etc. But as always, thank you all for watching. If you're new here, please consider hitting that subscribe button, hit the like button, hit the comment section below. Did you enjoy the video? What are your thoughts and opinions on the video? Have you come across any type of LFI or RFI in the real world? I'm sure you come across it in plenty of CTFs out there. Thank you for watching. See you later.